Okay, now I want to cover some more examples of finding the derivative implicitly. And our first example here is we want to find dy dx of the equation x squared plus 2y equals 3xy. So once again, our first step is we want to take the derivative of both sides with respect to x. So here we have d dx of both sides. And if we take the derivative here once again, our variable is x, so this variable matches up, so the derivative would simply be 2x. And over here, our variable is a y. It does not match up, so when we take the derivative of 2y, we would simply have 2, but then applying the chain rule, the derivative of y would be y prime. And on the other side, this is where you need to be careful. We have 3xy. So if you have to recall here, we have to use the product rule. So I'm going to group 3x times y, and the product rule says we're going to take the first term, which is 3x, multiplied by the derivative of the second. Well, the derivative of y would simply be 1, and then if we take the chain rule, that would simply be y prime. So your derivative would be 1 y prime, or simply y prime. And then the product says we want to add the second part, which is y, multiplied by the derivative of 3x, which is 3. So remember, we got to remember all of those differentiation techniques we've learned. So here we have to use the product because we have 3x times y. Okay, so if we simplify this, we would have 2x plus 2y prime. And I'm just going to rewrite this a little bit. We would have 3x y prime plus 3y. And now if you recall, we want to collect our y prime terms to one side. So we have 2y prime minus 3xy prime, and move over the 2x, so that's a negative 2x plus 3y. And then we can factor out the y prime, and we have 2 minus 3xy. Now, once we factor out the y prime, we can simply, whoops, made a mistake here. This should be 2 minus 3x. Once we factored out the y prime, we could simply divide the 2 minus 3x away. So we would end up with y prime equals negative 2x plus 3y over 2 minus 3x. And this is our derivative. And once again, notice our derivative is in terms of x and y. So for example, if I said we want to find the slope of the tangent line at, let's say, the point 1, 1. Well, we would actually have to plug our x and y value in, and we could find the slope. So we'd have negative 2 times 1 plus 3 times 1 over 2 minus 3 times 1. And then if we simplify this, we would end up with negative 2 plus 3, so that's 1 over 2 minus 3 is negative 1, so we have a slope of negative 1. So keep in mind here, this is the rate of change at 1, 1, or in other words, this is our slope of the tangent line at this particular point, 1, 1. So our slope is a negative 1. All right, here we have an example involving trig functions. We have the sine of x plus 2 cosine 2y equals 1. So once again, if we're taking the derivative, dy dx. Now before we get started, over here at the side I've made a note for you. Recall that when we take the derivative of a trig function such as sine, the formula says sine of u. Well, remember here, u is actually representing a function of x. So u is not just representing a variable such as x, but it's actually representing some function of x. So the derivative of sine of u is the cosine of u, that's the outside function, and then the u is the inside function, so when we take the derivative there, we're going to multiply by u prime. So this here is already showing you that we're going to use the chain rule to find the derivative of sine of u. So for our example, when we take the derivative of both sides, we take the derivative of both sides of the equation, we have the derivative of sine of x, and once again here the variables match up. Now notice here, if we take the derivative of our sine function, that is simply going to be cosine of x. And now technically, we would take the derivative of the x, the inside function. Well, the derivative of x would be 1, so we would just simply multiply by 1. And that's why before, when you looked at the derivative of sine, we didn't worry about multiplying by 1 because that's not going to change anything. But now, I want you to realize, though, we take the derivative of sine of x, that's really going to be cosine of x, and then the derivative of x would be 1. Our second term, notice here, once again, we have a y. So we're going to have to be careful because that doesn't match our variable. So now the 2 is just a constant multiplier, so I'm going to bring the 2 down. And now the derivative of our cosine function is a negative sign, so we would have a negative sine of 2y. And now we need to take the derivative of the inside. We need to take the derivative of 2y. Well, the derivative of 2y would simply be 2, but remember we have to take the derivative of y, which would be y prime. And again, that's because the y doesn't match our variable x out front. And the right side's easy, it's a constant, so the derivative is simply 0. So if we simplify here a little bit, we have cosine of x minus 4 sine 2y, y prime. Now remember, at this point we want to isolate our y prime. Now what I'm going to do here is, because we have a negative 4 sine 2y, y prime, I'm going to move that to the other side, so we would have cosine of x equals 4 sine 2y, y prime. And now we only have the one term that has y prime, so we can just simply divide everything away. So we have cosine of x divided by 4 sine of 2y. And there's our derivative. And notice again, the derivative is in terms of both the variables x and y. Okay, this example says we want to solve the following equation for y and then find the derivative explicitly. Okay, so if you notice here, we have 25x squared plus 36y squared equals 300. So if we're going to solve this or find the derivative explicitly, we need to solve for y. So to do that, we would move over the 25y squared. So we would have 300 minus 25x squared. And then we could simply divide by the 36. And I'm going to simplify this, y squared, we're going to simplify this. 300 over 36, that's going to reduce to 25 thirds, and 25 over 36 would be the same, so I'm just going to write this as 25 over 36 x squared. Now that we have a y squared, if we solve for y, that means we need to take the square root of both sides. So I now need to take the square root of both sides. And remember, when we take the square root of both sides, that means we need to plug in a plus or minus. So therefore, we're going to end up with y equals plus or minus the square root of 25 thirds minus 25 over 36 x squared. Okay, so now that we have the plus or minus, that's going to break our problem into two separate problems. So we could have y equals a positive square root, and since we're going to take the derivative, I'm going to rewrite the square root with a fractional exponent. So we'll just raise that to the 1/2 power, and then we'll do the same thing for the negative square root. So now, so far at this point, all we have been doing is we've taken what, 1, 2, 3, 4, 5, about 5 steps to solve this equation for y. And to do so, we took the square root. So now we have two equations. One's positive and one is negative. So now at this point, we're ready to take the derivative. So if we're going to take the derivative here, y prime would be equal to, well, 25 thirds. That would go to 0. And then we have the 1/2, I'm sorry, the 1/2 out front is our chain rule, so we bring it up to 1/2. So we would have 1/2 times 25 thirds minus 25 over 36 x squared to the negative 1/2. Now we need to multiply this by the derivative of the inside. Okay, so that's using the chain rule. The derivative of the inside, then the 25 thirds goes to 0. The 25 over 36, we have to multiply that by 2, so that's a negative 50 over 36x. Okay, and then I can collect some like terms here, or multiply rather, the 1/2 and the negative 50 over 36, so that would make this a negative 25 over 36 times x, and then all of this is multiplied by 25 thirds minus 25 over 36 x squared to the negative 1/2. So this here is our derivative. Okay, now you could do the same thing over here with the negative, and really the only thing that's going to change there is the negative sign. So once again, to find the derivative of 25x squared plus 36y squared equals 300, if we want to find the derivative explicitly, we have to solve for y, which took a little bit of work. Well, now I want to look at the same problem, but we want to find the derivative implicitly. So let's see how the difference is. Well, if we're going to take the derivative implicitly, then we can simply take the derivative of both sides. Okay, now keep in mind the variable is x, so the first one matches up. So when we take the derivative, we would simply end up with 50x. And now over here we have a y, so the derivative is going to be 2 times 36. We have 72y. But then we take the derivative of y, which would be y prime, equals the derivative of 300 is 0. So if we solve for y prime, we move over the 50x, so we subtract 50x from both sides. Then we can divide everything else away. So therefore we have a negative 50x divided by 72y. And of course this would simplify to a negative 25x over 36y. And if you notice from above, negative 25x over 36y is going to be the same as this equation up here, because we have, notice, and you're like, wait a second, this doesn't look anywhere near the same, because down here we ended up with y prime equals negative 25x over 36y. Well, recall, if I rewrite this problem, this is negative 25 over 36x, or let me move the 1/2 to the bottom here. If we move this to the bottom, we have 25 thirds minus 25 over 36x squared. So that now becomes to the positive 1/2. And you're thinking, well, that still doesn't look anything like a negative 25x over 36y. Well, recall over here, we took the derivative explicitly, so our terms are all in terms of x. And over here we have x and y. Well, if we go back up here, what does y equal? Well, we solved earlier, y is equal to the 25 thirds minus 25 over 36x squared to the 1/2 power. So if I substitute all of this in for y, we would have y prime equals a negative 25x over 36 multiplied by 25 thirds minus 25 over 36x squared to the 1/2 power. So now if we compare the two answers, they are the same. So I think, so quickly looking at this example, clearly it's a lot more difficult to solve for y and then take the derivative, whereas this problem only took us really 1, 2, 3 steps to take the derivative implicitly. So there's one advantage of taking the derivative implicitly. It's going to save you time and effort from having to solve your equation here for y.